What's up, Stone Squads? Today we're going to be talking about graphing rational functions. So rational functions just means that your input is in the denominator. The form you're going to use is this. A divided by x minus h plus k. If you understand transformations through any other functions, through even quadratic or even linear, we understand h and k tells you your horizontal shift and then your vertical shift. And the a value is the one that tells you if it's reflected or it's vertically stretched or if it's compressed. So today we're going to talk about that, but in the form of rational functions. So your parent function, so remember, parent function is like your parents, right? They're just a graph that, you guys are actually the transformed version of your parents. All right, you guys are the ones they might say like, oh yeah, you have your dad's eyes or your mom's nose, or you look just like your grandma. So you're the transformed version of your parent function graph. So your parent function graph is where the h value, there is no horizontal shift, there is no vertical shift, and there's no stretches. So 1 over x is actually your parent function. Couple things that comes with this, characteristics. There is a vertical asymptote at 0. Vertical asymptotes occur at the denominator. The denominator cannot be 0. So whatever makes the denominator 0, wherever that is, you're going to have a vertical asymptote there. And you're also going to have a horizontal asymptote at 0 as well. To graph this, we're going to plug in values. I will say plug in 2 values to the left of your vertical asymptote and 2 to the right of your vertical asymptote. So let's plug a couple examples in, like -1, -2, 1, and 2. If I plug in -1, you get -1. If I plug in -2, you get -1/2. If I plug in +1, you get 1. If I plug in 2, you get 1/2. So how does my graph look like? So you have -1, -1. You have -2, 1/2. And then you have 1, 1, and then 2, 1/2. So what you notice is you cannot cross your vertical asymptote. Think of it as like a wall, right? So then what happens, your graph goes and it curves, and then we get on that side, and we also get it on this side. So your graph, your parent function of a rational function looks like this. It's not 2 different equations graphed on the same coordinate plane. It is one graph. Right? It just breaks off here. So what is my domain? Your domain is everywhere left and right except at 0. So you could write it a couple ways. You could just say -infinity to 0, and then 0 to +infinity. And I'm using open brackets to let you know that you cannot be equal to 0, or you can never get to infinity. All right, your range is how far down, how far up. Well, that also goes from -infinity to 0. Stops there, and then it goes from 0 to +infinity. Right? Let's talk about transformations now, because that's the parent function. Well, when we transform this, let's just take an example. X minus 1 plus 3. I think of h and k. Where else have you seen h and k? That's your vertex. Remember when we found vertex be the opposite h comma k? This is very similar. This won't give us a vertex, but instead it is going to give us the intersection point of your horizontal and your vertical asymptote where they line up. So for example, 1 comma 3 would normally be your vertex for a quadratic function. In this case, it is going to be the intersection of where your vertical and your horizontal asymptotes cross. All right, so we always start there. And then after that, we just test points, left, 2 to the left, 2 to the right. Pick nice numbers, because we don't like dealing with fractions. So try to pick numbers where you'll get perfect numbers, like 0. 2 is a good number, because 2 minus 1 is 1. Those are the only ones that won't make it into a fraction. So plug in 0 here, you get 1 over -1. Which is -1 plus 3, which is 2. If you plug in 2, you get +1. So 1 over 1 is 1. 1 plus 3 is 5. So we find out at 0, 2 is a point there, and 2, 5 is a point here. If you remember your parent function, all you have to do is connect them. Follow your horizontal and your vertical asymptotes. So what is my domain? Goes from negative infinity to where now? Where's my vertical asymptote? At 1, and then 1 to infinity. All open bracket because we're never going to get there. My range, how far down? Negative infinity to where we're at now, 3, and then 3 to positive infinity. We can't cross 3, but we go to infinity and negative infinity. Alright, so that concludes our lesson with graphing rational functions. Let's get ready for our 3 videos. Alright, let's try our first example, our basic y equals 1 over x plus 1. Figure out where the intersection point of your vertical and your horizontal asymptotes are. Alright, I'm going to give about 30 seconds to a minute, go. Alright, so where is my k value? It's technically 0 if it's not present, right? So where is the intersection? Negative 1 comma 0. H value means, plus 1 means shifted horizontally left 1, and then we're not shifting vertically up and down. So let's start there. We always start there. So there you have a vertical asymptote negative 1, and you have a horizontal asymptote 0. Let's pick 2 values. Let's pick 0. 0 is nice. We can't pick negative 1. Let's pick negative 2. So let's try those values. Plug in 0, you get 1, so you get 1. If you plug in negative 2, you get negative 2 plus 1, which is negative 1. 1 over negative 1 is negative 1, so you get negative 1 there. So we have 0, 1, negative 2, negative 1. And if you remember your parent function, how does your graph look? It's going to look like that. Alright, what's my domain? All the way left, all the way to negative 1, and then you go to negative 1 to positive infinity. What's my range? How far down? Goes to negative infinity to how far up? 0. And then from this other half, you get 0 to positive infinity. So check your answers. You know, maybe you only got the asymptotes correct. That's a great start. Let's try it. Let's get ready for our intermediate level problem. Alright, intermediate level problem. Let's try this. Do 2 over x minus 3 plus 1. So lots of things going on. You have a value, you have a horizontal shift, you have a vertical shift. Try as best as you can. Don't ever give up. I'm going to give about 30 seconds to a minute. Go. Alright, let's try this. Where are we intersecting the asymptotes? At right 3, up 1. So right 3, up 1 is my intersection. So you have a vertical asymptote and a horizontal asymptote. Test some points. Don't worry too much about the 2. The 2 tells you it's a vertical stretch, but you'll see that while we plug in values. So let's plug in nice numbers so we don't have to worry about fractions. So like, let's try to get 2 over 2, or 2 over negative 2, so then it becomes a whole number. So like 1 would be a good number because 1 minus 3 is negative 2. So 2 divided by negative 2 is negative 1. Negative 1 plus 1 is 0. Let's try another value. What's another good value? 4. Why is 4 a good value? Because 4 minus 3 is 1. 2 divided by 1 is 2. 2 plus 1 is 3. Alright, what else is a good number? Good, try 5. Why? Because 5 minus 3 is 2. 2 divided by 2 is 1. 1 plus 1 is 2. So I'm not picking values like 0, 1, 2, negative 1, negative 2. You know, where we're at now, we start figuring out ways to make our life easier, our math easier. So I'm picking different values. So I have 1 comma 0, 4 comma 3, 5 comma 2. You realize it is like a parent function. It's going to shift there, and then it's like that. My domain is what? How far left? How far right? It stops at 3. That's this side. Now we go to this side. It goes to 3 to positive infinity. My range, how far down? It goes to negative infinity. How far up? It goes to 1. That's this bottom half. The second half, it goes to 1 to positive infinity. So check your work, check your math. Try to pick values that makes the problem a lot easier. Alright, good job. Let's try our advanced level problem. Alright, our final problem, our advanced level. Here it is. Negative 3 over x minus 1 plus 2. We didn't really talk about what the negative does. If you guys recall from quadratic functions, it works the same way with your a value. That's your hint. Just try your best. As long as you graph your points correctly, you should be able to see what the negative does. I'm gonna give you about 30 seconds to a minute. Good luck, don't give up, go. All right, let's try this. So 1, 2 is my intersection of my asymptotes. So you have vertical and a horizontal. So right 1, up 2. Let's test some points. Well, the numerator is -3, so let's try to get the denominator 3 or 1. So what's a good number? 4 is a good number, 2 is a good number, 0 is a good number. So if I plug in 4, 4 minus 1 is 3. -3 divided by 3 is -1. -1 plus 2 is +1. If you plug in 2, you get 2 minus 1, which is +1. So when you divide that, you get -3. -3 plus 1 is -1. If you plug in 0, you get -1, so you get +3. +3 plus 2 is 5. So you have 0, 5, 4, 1, 2, -1. So your graph is going to look like this. Alright, so what do you notice when A is negative? Yeah, instead of these two quadrants, it's going to be on these two quadrants, so it's going to be a reflection. So hopefully you're able to see that. My domain, how far left, how far right, it stops at 1, but then it continues from 1 to infinity. Your range, how far down, which is -infinity, to where? 2, and then 2 to +infinity from the second half of the graph. Alright, so check your answers, check your graph, check your tables. Just be careful with negatives. I threw in a lot of negatives in this one. But that concludes our lesson with graphing rational functions. Hopefully these videos helped you, especially this lesson. If it did, please subscribe to my channel. Please turn on your notification. Let's get ready for some more videos. Thank you.